We have been building the Fractals and Recursion project from the YByte Python curriculum available at www.ybyte.in. Previously, we have seen how we use recursion to create, let's say, a square pattern and then this tree. The code is very less, but the way it works is quite fascinating, and the outcome also is quite fascinating. Before I wrap this up, however, let's take another example where we generate Fibonacci numbers using recursion. And this recursion uses two recursive calls, just like our tree. Now, Fibonacci numbers are very interesting, found in lots and lots of places in nature, lots of applications in mathematics. The basic rule is that, look, Fibonacci sequence is a sequence of numbers where the first zeroth number, let's say 0, first number is 1. And thereafter, I just sum up the previous two Fibonacci numbers to, for example, get the next Fibonacci number. Now, to see this in example, 0, 1, F2 is 1 because F1 plus F0 is 1 plus 0, that is 1. F3 is 2 because 1 plus 1, that is 2. F4 is 3. That's because I'm doing F3 plus F2, so that's 2 plus 1, which is 3. F5 is 5 because F4 plus F3, that is 2 plus 3 is 5, and so on. In fact, this, like I said, is a very fascinating series, lots of interesting properties. One such thing you might have seen before is this thing called Fibonacci spiral. So, looks quite nice actually. To implement this in a Python code, I can write a recursive function. Remember, n equals to 0 and n equals to 1 are my two base cases where the recursion stops. So I just tell, well, look, if n is 0, return 0. If n is 1, return 1. Else return Fibonacci n minus 1 plus Fibonacci n minus 2, because basically it's, that's the formula that we have seen. Let's see this working in code, and then we'll come back and analyze this in some detail. And we'll see how, in fact, this is very, very similar also to our tree case that we've just studied. So I come here to my code. I've already written this function. I have this Fibonacci, numbers available to me. Let's say I try Fibonacci, let's say 5. That returns me 5 because indeed it is 5. Let's say I try Fibonacci 10. That's 55. Fibonacci, let's say 19. That is 4181. In fact, I can verify these from here. Remember, F5 was 5, F10 was 55, and F19 was 4181. So indeed, my function is working correctly. But the question is how exactly it is working, what is going on here. A deep dive into that is actually quite interesting. So when for example, this tree looks complicated, but let's analyze this slowly. Basically, when let's say, give Fibonacci 5, let's try to visualize this. So I ask Fibonacci 5. Remember, Fibonacci 5 is going to cause a two-level recursion. Essentially, I'm going to call Fibonacci 4 plus Fibonacci 3. But Fibonacci 4 itself will decompose into two recursions. So Fibonacci 3 and 2. 3 will decompose into 2 and 1. 2 will decompose into 1 and 0. But this being the base cases, I will return a 1 from here. I'll return a 0 from here, which means this value will be 1. 1 plus 1, this value will be 2. Now, again, there's another branch of recursion going on here. So 2 decomposes into 1 and 0. This hence totally is actually 3. Now taking the other branch, I get decomposed into, let's say, Fibonacci 2 plus Fibonacci 1. This is where recursion stops. This guy further recurses, and I travel back upwards. You will realize that 3 plus 2 is indeed 5. Looks very complicated when I have such small numbers, but just imagine doing this for a bigger, let's say, Fibonacci numbers. The reason I have drawn it this way, and also along with the branches, let's say along with, the way these, let's say, arrows, is because I want you to realize that this is in some sense quite similar to the tree that we were doing. One branch leading to two other branches, further leading to 2 branches, further leading to 2 branches, till I reach the base condition and this stop. Now this, I think, is an apt moment for us to wrap up this set of videos. We started with this premise that, look, fractals and recursion go hand in hand. They create a win-win situation. And through this series, and throughout this series of videos, I've tried to give you examples which reinforce this notion. We see that recursion is a fantastic way to generate fractals, although of course we limit them to being finite. And conversely, we see that fractals are a great way to understand and visualize recursion, as we are seeing through this example. So I hope you have enjoyed this journey. Recursion can be a little bit confusing, which is why I've tried to go, as detailed as I can. As always, I'm more than happy to hear your comments, answer your questions that you may have. But enjoy programming, enjoy recursion, because it is really quite interesting. Once again, at YByte, we want you to experience the joy of programming the way we do. Look at our website, www.ybyte.in, because we have many activities through which we learn Python programming in a fun way. Take care. Thank you so much. Bye-bye.